So I'm Manber. I run the search quality group here. We're responsible for ranking. So if you do a search and the results don't get you what you need, it's my fault. I've been doing search for 20 years. I've done it in other companies as well. But let me go directly to the slides. I'll start actually with something that may go against the grain of some of what you're talking about, but I'll do it anyway. And I try to make a pretty bold statement, which is that so far we build the infrastructure. We build an amazing infrastructure, and not just computers. We build dams and airplanes and roads. That's what the 20th century was. We more or less conquered nature, at least the first step. Now comes the next step. How do we get people? How do we understand people? How do we get societies to be better? How do we get education to be better? How do we communicate better, and so on? If people people study social science for a while, it's going to be very different with instant communication, Facebook and Twitter, and of course search. We are getting into a whole host of different applications that will completely change how we live. So I'd like to think, of course I'm biased, but I'd like to think that the 21st century will be about understanding people in particular. So it's a lot more the infrastructure. Now that we have the infrastructure, what do we do with it? We have now the ability. We have DNA. We have instant communication. We have all the facility. We have all the ability to do that. I like to think that search is one of the leaders in this area. And I'll show you some of the things that we're doing. Of course, I'm limited. I can't talk about, we don't pre-announce things, so I can't tell you about things that we haven't announced yet. And obviously, I can't talk in detail about the algorithms we use, but I can show you lots of the stuff that we're doing. I like the analogy to rocket science. That's what kind of triggered a lot of the science of the 20th century, almost about 50 years ago. John Kennedy stood before everybody, said we're going to send a man to the moon, and that was incredibly exciting. I can't do something like that with understanding people. It's much more subtle than that, and of course I'm no Joe Kennedy. But I like to think of what we do as sort of rocket science. In fact, I would argue that we sort of do rocket science that you take for granted. This is our new type of rocket science. I call it quiet rocket science. You can't actually tell that it is. You completely take it for granted. It's there. It works. And that's exactly the way we want it. That's exactly the way it should be. Okay? So let me start with a really, really trivial example. And I chose this example because my daughter sent it to me. She keeps sending me examples of things that don't work. Once in a while, she sends me examples of things that do work. And this is an example where she was looking for a particular music store, Griffin Music, Palo Alto. If you notice, the spelling is completely different. The name of the store is Griffin. In fact, spell checking didn't catch it. There is no "did you mean." Synonyms didn't catch it. It's way too far from that. The match is not particularly good. Palo Alto none of the words appear in the title. Palo Alto is somewhere in there, and music is actually not that high. Talk about American music somewhere on the page. Yet, not only did we find it, not only did we put it at the first position, we even added, if you notice those things, we call them site links. That means we are pretty certain that that's exactly what you meant. So we gave you some more information into the site. So you take an example where the match is very weak, but we really know what you meant. This is also an example where you probably wouldn't have thought twice about it. You did the search, you got the results, you go there, everything works, everything fine. You don't see how much smartness goes into something like that. Okay, so let me go back and start talking about search. So search is much harder than you think, even after taking that into account. It's really, really hard. And in particular, the point I want to make is expectation grow. Whatever we solve today, tomorrow is going to be harder because people need more, they want more, and they expect us to do more. I think at some point in the last few years, we crossed the threshold from you go and do a search and you feel lucky that you actually found the result, to you go and you do a search, and if you didn't find the right result, something went wrong. Somebody did something wrong, right? You expect to find the right results. This is a nice it doesn't mean that you always find the right result. We didn't go from 0% to 100%, but it's in people's expectation, we made a big difference. So when we do search here, we obviously have huge amount of resources. We have lots of storage. We have lots of machines. We have lots of everything. I couldn't resist when I put this slide together. I'm using PowerPoint. PowerPoint resisted the word petabyte and suggested, maybe I meant megabytes or petbytes. So besides the urge to make fun of somebody else, there is a point here, which is when we designed spell checking, we didn't hire a few linguists to figure out how the language works. We hired very few engineers to figure out how to handle the data. So our spell checking is updated all the time. It's recent. It really is dependent on the vast amount of data that we get that's out there. So the results obviously have to be very fast, very relevant, very comprehensive, and as fresh as possible. Right? These are all obvious characteristics. We have teams, reasonably large teams, working on each part of that. But my main point is even that's not enough, right? Because we always have to start from the most important thing, which is we have to solve the user's problem. This is what we need. This is what the user is asking us to do. We always have to think about the user. And I'll show you several examples of that. But in general, I like these slides very much. If there's any problem, we see it as our problem. If a user can't spell, it's our problem. If they don't know how to form the query, it's our problem. Even if they don't speak the language, it's our problem. If the information is not there, it's our problem. If the web is too slow, it's our problem. We have to look at the whole problem, and we do. And we'll see examples of each one of them. Just quickly, we make tons of changes to search. Most of those are invisible to most people. They're transparent. You take it for granted. Your search gets better and better all the time. So it's not something that, going back to the rocket science analogy, you don't hear this huge rocket goes up and all the excitement around it. It's just things get better. We build a nice system to allow engineers to innovate very quickly. It's all based on data. We know how to analyze results. We give our engineers all the infrastructure they need so they can run all the experiments. They have their own copies of the web. They have own copies of everything that's running. They can run things. They can figure out how well they're working. We minimize the friction. This is just, I put several slides of the kind of graphs. We look at hundreds of different graphs every day. We have dozens of mathematicians and statisticians and computer scientists who do nothing but evaluate how good the results are. That's one of the secrets of search, is that you have to know how to evaluate. Let me very quickly tell you, I don't know how many of you know how search works, so I'll spend 2 minutes just give you the basic. It's actually very simple. The way we do search, we analyze every document. We take every word in every document, store it in a word table with a pointer where we found the word, right? When you put several words as a query, we look at the location, the list of all the documents that contain this word intersected with the list of all documents that contain that word, and so on. We get the list of all documents that contain all the words. Each document is also associated with some weight, some importance of the document. PageRank is one such example, but there are many other parameters, many other ways to evaluate it. And then there is this, this magic step happens. The ranking function takes over and picks up the first 10 results, or first 100 results, whatever you ask for. That's kind of the most important step is how do you take those usually millions of results and find the best one? But we do better than that. This is way oversimplifying. We're trying to understand things. I can't say that we understand things in the full AI notion to really understand, but we come as close as we can, which is we don't just look at the document as a collection of words. We try to understand connection between words, inferences. We summarize the document. Then we do the same thing for your query. We somehow summarize your query, more than just your words. There are a lot more than that. And then we somehow figure out a way to summarize those, and to match those summaries. So there's a lot more going on in a search than just, the old 40-year-old Boolean, match this plus match this, do an intersection, and be done with it. Here are some examples of what goes into such summaries. It could be a language. So we understand that childcare with a space is the same as daycare and childcare without space. It's not just spell checking, it's usage of words. We understand time. And time is actually very hard to work with. You can argue we always should give you the freshest results. That would be wrong. Some queries you want to know what happened today. Some queries it doesn't really matter when the document was written. You want the best document. And if it was written 2 years ago, that's absolutely fine. It really depends on the query. Place, we understand places, so we can tell that one place is close to the other, which means that there are similarity. We understand context. We'll see examples of that. And obviously, we want to understand you. So we put a lot of effort into personalized search. Let me show you some examples. At the end of the day, I spend a lot of my time just looking at random queries. A lot of my team just looking at lots and lots of random queries because that's what it is. And you get some insight if you start seeing what people are searching for. In the back of your mind, you're thinking about what you're searching for, and you think that this is it. In fact, it gets very, very diverse. So here's some examples. This is an example. These are all examples of random queries that I just picked up. Again, I'm looking at lots of queries. Trying to figure out the user intent. That's always one of the most important and difficult things. In this case, it looks like what they're looking for is a particular Excel program that does something like this. If you know computer science, you know how hard that is to look for a program that does something like this. If there was a program with those words, obviously it would be easy. But doing something like this is not. This is also pretty clear what the user was looking for, although the form of the way the query was formed is more talking rather than actually querying. Sometimes, this is probably very important. This may be less important. But it may be very important. When I look at queries, I only see the queries. I have no idea where they come from, nor do I care. No, I want to understand the person intent. But this could be very, very important to that person, for all I know. Here's how specific it could be. These are, again, just random queries that I picked out. Here's another very specific. I actually spent quite a bit of time to look for this. It turns out there was a crash 2 days before in southwestern Utah. That's how hard it is. Sometimes, I keep saying that no queries are bad. It's always our fault. But some queries get close to it. This is an example of a query that's, pretty hard to do. We could probably build a system that can do that, but I'm not sure it's a good thing. But we get queries like this. This one is a query that's interesting. See if you can figure out the intent of this query. Anybody can guess? Because I have a guess. I have no idea because I don't know who did this. No. That's it. Again, it's all guesses. No. We don't know, but here's a good guess. My guess is the person typed this into Google, I'm going to win the lottery, and then click on I'm feeling lucky. That's my guess. And I gave a talk with this example, and somebody raised his hand and said, yes, I did that. Let me give you another example. And the example here shows that a good and interesting point, which is what we need is to give you what you need, not necessarily what you said. That's a distinction. The query is, how many calories in a pound? What is the intent? I did this query, so I'm looking at this random queries, and I did the query, and it turns out that Google generated the result right away. There was a one box on top, and they gave the results. And the result was, 9,000 trillions. 9 times 10 to the 15. How do we get that? I would argue that's actually the correct answer. It came from the Google calculator. The Google calculator knows how to transfer between units. Look at the question. It asks how to transfer a unit of mass to a unit of energy. Pound is a unit of mass. You want to convert it to a unit of energy. We know how to convert mass to energy. There's a formula for that. That's the formula. Okay? So,
that's Haagen-Dazs ice cream.
Actually, my interpretation was, think of this poor user who looks at this and says, I probably shouldn't have had this quarter pounder. Right? It doesn't. Those 9,000 trillion calories don't feel that good right now. So the point is, we gave the correct answer, but it wasn't the correct answer. It's not what the user had in mind, and we did a disservice. So this was removed the same day. I wish I'd kept a copy, but it's no longer there. And you can see the problem. It's not enough to look at just straight answer. You really have to understand intent. Okay, so let me give you more examples of the kind of new things that we've done in search that really improve how you can find things. So we know where you are, at least for many people, either because you told us in many different ways, or because we can take it from your IP address. And so if I go and I did a search for 500 Magdalena Street, it turns out there isn't any mention on the web for this particular address. It's not far from my home. And there was some discussion of somewhere in Philadelphia, and there is St. Magdalena on Flickr. But we know that I did this query for Mountain View. There is a street called Magdalena in Los Altos, not too far from here. We gave you an address and a map directly on that street. You don't actually have to say which town it is, because we can take that into account. And even better example, if I just search for plumbers, it figures out that, well, you probably want plumbers near Mountain View. And give me a list of plumbers. Okay, so results are much better just because we get more information. We can get you there faster. Speed, well, you know that. Speed is usually the killer app. And it's amazing how many people don't know that or don't realize it. So here's a very small thing that we've done. You know those flash introduction that some sites have? We don't like them because they just slow you down. In fact, if you go to that site, I pick something that I hope I don't offend anybody here, but if you go to that site, that's what you get for a while. Don't know why they think it's a good idea, but we build a system that allows you, if you so wish, to skip those. We can do it automatically. Small thing, but interesting. Let me actually skip this example. I'll go back to it maybe later. We try to use as much data as we can, not necessarily just web pages. Here's a simple example. If I search for Alaska 301, we'll tell you the exact status of that flight as we speak. We'll give you real-time data about what happens to that flight. That's probably what you want. Because if we just search the web for that query, it turns out this is the first result for that query. Because it is actually the best result. It's the only result on the web that Alaska 301 is the title. It is a pretty good site. It's Flickr. It just turns out to be, well, not that relevant, but you have to look at it to know that.
Actually looks like the status of Flight 301. It's very bumpy flight. He's about ready to flight.
Okay. So if you want historical data, maybe that's correct. Translation is a big deal. You know, most of the people in the world don't have access to most of the information because they don't speak the language. We want to solve that. We have a lot of work on automatic translation, and we put it into search. So here's an example. You go to, this is in Egypt. If someone searches, and again, it's a real query, they search for Disney movie songs. At the bottom of the query, right there, what it says is, look for results translated from English. If you click on that, you get to this page. You can go to this page directly and search from any language, or not any language, but many, many languages to many, many other languages. And what it does is it takes the Arabic query, translates it to English, does the search in English. In this particular query, chances are that the English web has much better results than the Arabic web. takes the results in English, then translates the results back to Arabic. So if you only speak Arabic, you're just looking at this area. It's only in Arabic. You get the Arabic results that you want. If you click on one of those, it will automatically translate the whole page to Arabic for you. So translation is not perfect, but you cannot get access to that information without speaking the language. Again, it's not that easy to do. It's not just translation. We have to figure out when to do it and when not to do it. Because for a lot of queries, they might be local. You don't actually want to translate from the English web. And of course, we have to worry about abuse. Not everybody plays by the rules. There are tons of examples. We have a large team that deals with that. In a large degree, we kind of, I wouldn't say we beat it, because we have to, to work on it every day. But it's definitely much better than it was 3 years ago. Let me show you some examples. Let me take, this looks like a real content, but in fact, if you look at it, for every different disease, it says the same thing. Or take this example, a particular blog, which if you look at it, well, it doesn't make any sense. But the search engine has to be smart enough to read this and say, no, that doesn't make any sense. That's not real content, even though it uses good words, and I should ignore that. We're doing things all the way to trying to figure out how much information to give you in the search results. We call them the snippets. In the snippets, so that you can make a determination whether you want to go to that site or not. So if the query is longer and we think we need more room, we'll give you a longer snippet. If it's shorter, we might give you a shorter snippet. We work a lot to understand the query in such a way that we can give you other suggestions. In this case, it's a good example. Principle of physics, well, angular momentum, Big Bang. These are not the same strings, but they actually have the right meaning. Let me go quickly. This is a good example. I like this story. I was actually looking for a talk. This is different time. I need to prepare a talk. I wanted to take a previous talk, copy some slides. I couldn't find it on my desktop. I was looking at my laptop, couldn't find the laptop. I was looking at the backup tape. I couldn't find it there, and then it hit me. I just searched Google for it. Turns out the talk was public. Somebody copied it. It was on the web. I found it much easier than going to backup tape. All kinds of nice examples. Let me go quickly through it because I want to leave room for questions. I think we will see, as I said, expectation grow quite a bit. And my best analogy there is disk drives. I have orders of magnitude more disk drive today than I did 20 years ago, and I run out of disk more now than I did 20 years ago. Right? We want to fulfill those expectations. I'm a big fan of cartoons. I took this cartoon to be the sort of the logo of our group. In fact, somebody took that and made even better cartoon out of it. And let me end there. Any questions?
One of the things I've noticed that it feels like it's a deep secret because I just wasn't aware of it. It could be I'm just ignorant. Is that when you type stuff into the Google search bar, it actually does computations and tries to literally answer questions. I mean, if you put in a request of what's 50 degrees Fahrenheit in centigrade, it does the computation. There appear to be quite a few cases along those lines. Do we document that anywhere, or is this one of those things that spreads by virally, or what's the story there?
Documentation is hard because people don't tend to read documentation. In fact, we upgraded the help pages recently by quite a bit, and I say it with all the bias possible because I wrote the new help pages. Not too many people go there, unfortunately. I really recommend that you do that. It's very short. It's only 2 pages, but it gives you quite a few of those examples and tell you about that.
So it's the.
But let me just the basic answer though is you don't have to know any of this. You just have to think. Go to the search box and tell us what you need, and we will have to figure out what you need and answer your question. This is why we're looking at the logs all the time and find out what people are missing or what doesn't work, and we edit. We don't want you to learn all the different syntaxes and all the different ways. We wanted to make it as simple as possible. You just tell us what you need.
Well, I guess I'm going to push back a little bit on that because I think if I had, maybe I'll go look at the help page. So if I had seen examples of things I could reasonably do, I might be inclined to try to do them. Whereas before, it wouldn't occur to me to do that. I guess that's the issue.
by saying we don't want you to do this, meaning we don't want you to have to do it. Of course, the more you learn, the better you are. So I'm not against learning in any way. Don't take that. But our goal is to solve all the problems without the need for a learning syntax. Yes.
Yeah. Sort of two questions. One is the enterprise search that I think you sell as a separate sort of product have different issues than you have for the internet type search? That's one question. The other one is you said you wish you would have saved something, and this triggered a thought in my mind when Google, I guess Earth came out recently. It added underwater, but it also added history, so you could go look at a place that it used to look at. And I remember in the audience, Gore noticing the lack of ice and changes and things like that. Do you now, will you, whatever, maybe you can't answer, keep historical views? Will you be able to do searches back in time? Do you have that capability?
I can't answer that. In this case, it was a bug. So it wasn't historical data. It was just a bug that it was triggered in the wrong time.
Right? But you had an engine. I mean, you're evolving the search engine as a function of time.
Sure, no,
too.
I completely understand the need, and I understand completely what you're asking. But I can't announce something that hasn't been announced.
The other one was the enterprise.
The enterprise, this is not part of my group, so I don't know that much about the enterprise. Yes.
Just out of curiosity, how many of these inferential routines do you have?
I'm not sure what you mean by inferential routines.
You speak of these as basically sort of learning a pattern.
Right.
How many of these? I mean, it must be just an enormous number of patterns.
So the code is complex, but it's not a collection of if then else. It's much more complicated than that. Obviously, we have learning mechanism, but we have lots of other things as well. I think I computed at some point that more than 1,000 man-year went into the search code already. So it is, when I say rocket science, it is actually very, very complex.
Yes. So how has Google affected the connectivity of the graph, like the degree of the nodes? Like before Google search, I mean, most of the people had to put like hyperlinks from one page to another.
Right.
How did that change? I mean, maybe it was because of Google. Maybe it was like a different effect. But like how is the connectivity of the web?
Right. That's a good question. I don't have empirical information for that. I've never looked at that. But I think if I were to rephrase your question, 15 years ago when the web started and Yahoo started collecting a list of things and other people collected a list of things, it was very important because the only way to find something is to find a list. Then Google came along and you don't need a list anymore. You just put the query and you got it. So there's less incentive for people to create lists. Right? You don't need lists. You can just search Google. That may suggest that people do less links because they don't do the work. As it turns out, my feeling is people found other ways. I mean, they then write blogs and the blog want to point to an interesting thing, or they Twitter and they point to something. They find other reasons to point to interesting things. That's one thing. The other thing is, of course, we improved our algorithm. And we don't depend just on one thing. We see how the web evolves. We see how things change. We adapt to it, right? So we can do just as good job, in fact, much better job now. But I suspect people are studying the sort of the historical change in the web connectivity. I'm sure there are some results in that. I just don't know what they are. Okay. Thank you very much.
Okay. Would you care to characterize the kinds of problems that are still really hard? That if there were some specific nuts you would want to crack, what would they be like?
Okay, let me mention a couple. One is inference, of course, knowing that this implies that. The other one is connecting things. That is, if you search for one thing and you know what that thing is, we'll find it for you. If you search for one thing and you mean something else, or you search for what's the effect of this on this, well, we have to take two different things and somehow connect them. We have to make some kind of inference, or more than inference. We have to make some analysis of language or analysis of something, that gets to be much, much more complicated. I'll give you an example of something that happened to me. I wanted to have a monitor that swiveled. I wanted to move my monitor back and forth. So I was looking for, a swivel monitor. And there are some. It's kind of expensive. But I found some, and I kind of thinking about whether to buy them or not. And I think accidentally, I don't remember how it happened, but then I realized that there are actually monitor arms that can attach to any monitor. There's a standard. And those things swivel. They're much less expensive. I don't have to replace my monitor. It's not a special monitor. It's just an arm you can buy for $50. If I had known by searching swivel monitor, it will tell me, you know what, this is the problem you have. You might be able to solve it with something else. We're very close to this. Very often we actually will tell you through the refinement or through other ways. I'd love to do a lot more than that. That goes into understanding. This is something we can solve. I think to some degree we are solving it already. I'd love to do more of that. How much? I think we're going to win. Because now you open it to selling more things, right? It's not necessarily that I'll buy cheaper things. I may buy more expensive things. So now I'm looking for one thing, but in fact it turns out there are 5 other things that I might be interested in. If anything, I think that'll be better. But there is, if I didn't say that, there is a very clear distinction between advertising and search. I work on the search part. We don't think about advertising. We don't think about revenues at all. Yes.
This is a question that got asked of folks from YouTube and Facebook and Maps Earth yesterday. To what extent are you constrained by infrastructure? Are there problems in your space that you're having to work around because the way that you want to do it isn't supported by the infrastructure underneath, or
okay.
And yeah.
So obviously we completely, absolutely depend on infrastructure. The stories about the pigeon rank and all those goats that are going around, they don't help search at all. It's all infrastructure. We have very good infrastructure. I don't often get into a situation where I say, well, I wish I had better infrastructure. That's what's stopping me from doing that. It happens once in a while. And definitely we're trying to get better infrastructure. We're trying to make it cheaper. We're trying to make it more efficient. We're trying to make it faster and so on. But we're not in a situation where that's the main blocker. The main blocker is ideas. The main blocker is software. The main blocker is development in search. Having said that, I think, and that's because I think we sort of, again, passed this threshold. I think 5 years ago there was a limit on how many pages you could search. It almost doesn't exist now. We really can search almost the whole web. I'm not an infrastructure guy, so maybe I'm underestimating, because it's very possible that next week somebody will come up with this unbelievable breakthrough in infrastructure. It will allow us to do a lot more. Yes. So that's definitely possible.
I'd attempt to paraphrase. There was a question that was asked yesterday that I think was more than actually infrastructure. I thought the question he was asking of several startups was, what elements of the internet, held you back technologically? So, and this is actually hard to do because you live within the constraints and you don't get to change them.
That I have a very, very
So the interesting question is, what things should change in the world? And this gets closer to the significance of this meeting. What things do you wish had changed, are changing, and you want to change that could really improve the world of search?
Okay, so I thought the question was internally, what I can do better. For outside, the question, to me, the answer is very, very clear. Speed, latency. The difference in your behavior with content, if it's 50 milliseconds faster, not to mention 2 seconds faster, is enormous. You really interact with it differently. We have lots of experiments. We're running all kinds of different user interfaces experiment. And I can tell you personally, I see myself, I didn't think about it before, I see myself interact with content completely different if I can get it within less than a second or if I get it in 2 seconds. And you think, why the hell would be such a difference between 2 seconds? There's a huge difference, 2 seconds. If there's anything I can do is really ask people who design websites to think about their user and try to make it as fast as possible for them. There is a sort of a maxim in the fast food industry that 6 seconds faster serving of food is 1% of revenues. If you can do it 6 seconds faster, that's 1% of revenues. I don't know if it's on the web, if it's 6 milliseconds or maybe 60 milliseconds, probably in between somewhere. It's definitely not 6 seconds. Okay? And the seconds is not just the time it takes you to render. It's the time it takes the user to get what they need. If you put an extra page in between and it requires an extra click, whatever you do, think about every millisecond that you cause the user to wait more. It's unbelievable loss of revenues for you, but it's loss of usability for the user. We are completely religious about latency. I can see that Bill is here. Thank you very much.
Terrific. Right. Okay, well, this is a special treat because Bill Coughran is one of our most senior people in the company, and to have him take time out of a busy day means a great deal to me, and I hope it means a lot to you as well. In the course of composing this symposium, I mentioned that I had left out search. I also left out cloud computing, and I was beaten over the head and shoulders politely for that, and then cast about to figure out whether there was someone who was willing to take some time to talk about it. And Bill kindly offered to give us a kind of a sense for the sort of the state of cloud computing and its significance in Google's world. As you can imagine, it looms very large in our ability to do the things that Udi was mentioning faster and faster. So, Bill, I really appreciate you taking the time. I'll turn this over to you, and you've got 15 or 20 minutes to go.
Yeah, great. So I've been in the computing business for quite a while, maybe not as long as some of you, but I've seen cloud computing appear as a possibility multiple times. And it's always failed for a variety of reasons, some of which are technological, and I'll talk a little bit about some of that. Some of it actually fails because of public policy reasons and so forth, and I'll touch on that. So these are slides that just kind of set the framework, and I'll rather than talk to them there's no detail here. There's sort of cartoons to talk about the developments over the last few decades. We've basically gone towards the personal computing model where everybody gets to be an IT specialist. Everybody has to figure out how networks work. Everybody gets to figure out how to remove spyware and malware and whatever ware gets on your computer that you wish you didn't have. It's clearly reduced our ability to do large-scale computation and storage. We're very limited. Although I am amused these days that personal computers, I think, have about as much oomph as the early Cray computers I used in my younger days. So things have changed a lot. I think the internet is taking us back towards the sort of the cloud computing model, and it's come a long way in that direction. And I want to talk about what Google's trying to do here. I think, and I'll talk about what's in our way. So we've launched a lot of products. We've launched a lot of research ideas and so forth into the community. We believe that the right model for the end customer, the thing that would make the end customer happiest, is if the devices that you worked with were stateless. By that I mean the devices become throwaway, and they're probably evolutions of your cell phone. We can debate that. I think, I see all of you busily doing your email or, doing whatever you're doing on your laptops, but I think I see an evolutionary path, particularly with things like netbooks and other things evolving, where it will become possible to hit much different price points with fairly large screen devices if people wanted to do it, and get your data in the cloud. So we're trying to enable that. We've put out things like online documents. We've put out things like App Engine. We have other things in the works that we're planning to put out. We're trying to enable some new developments in the mobile area with things like Android and so forth, where we're trying to help change the dynamics of the operating system and application offerings on mobile devices, and we're going to do more in that space. But basically, what I think of as cloud computing is get the user data out of their homes and out of the devices they carry around and get them into the cloud. Now, there's all kinds of technical challenges, right? People want control of their data. They want to be able to get their data back. There's questions about cryptography and encryption and what can governments do to me to see the data that I have and so forth. So there's a whole bunch of public policy issues connected with that as well. But my belief is that a lot of people would prefer once they've sort of figured out their address book and what they use for their day-to-day computing and thinking about, how they go about their lives and so forth, how they do shopping. And so it would be better not to have to copy that data around and reset settings in every device and so forth, but that would become part of the cloud. And so we're moving towards that vision. I think this vision has happened before. I saw it probably in a clear form probably about 15 years ago, and it didn't happen. Partly, I think, because there was not sufficient wireless connectivity and there wasn't sufficient wireline connectivity, at least in the developed world, where it was possible to, make that go. I think there's now enough networks built out. Sadly, I think the networks are better outside the United States than they are inside the United States, at least in the sense of last mile and wireless. But nevertheless, I do think there's enough connectivity now for people to actually do more of their computing. I think the other thing that's interesting for cloud computing is, so we want to enable things like making the cloud more accessible and make the client more powerful at the same time, but stateless. But one of the interesting things that Google has is lots of data. So one of the things we get requests for all the time is, can we get access to the data you collect? So, we've exposed things like a lot of the geo data we have through Maps APIs, and we're exposing other APIs. People, I think, would like access to our web repositories and so forth. And so we're kind of debating lots of interesting questions about what do we expose and what don't we expose. And of course, as a for-profit enterprise, we really have to think about, what's a business model that makes sense. At the same time, we're trying to figure out what would be useful for our user communities. But I think one of the things that will happen with cloud computing this time, and you see it happening, is you'll see people wanting to access interesting data repositories. And I think that's going to be part of this cycle. When I saw this 15 years ago, and then again probably 7 years ago, try to come to fruition, there wasn't really the data sources and repositories available that there are now. And I think that will be an additional driver towards actually making it happen. Now, it'll raise interesting questions, because you won't be surprised to hear that Google's advertising customers would love to get access to data we have about people. You've seen some of the companies that are working in the social networking space have stubbed their toe a few times trying to figure out how to monetize their properties by essentially selling data about people. So there's some, once again, I think one of the big difficulties in this area is the data about what people are interested in is very important, I think, to this initiative. But how to do that in a way that doesn't necessarily expose individuals and what they care about, particularly people who are sensitive to privacy, is going to be a real challenge. And one of the things I've noticed is, I have college and post-college age kids, and they were very comfortable posting everything about them on the internet, and they were, like to blog and give away information. becoming less and less comfortable with that. And I think they're also finding that the internet has this terrible propensity to remember everything they ever posted. It seems to be the fault of this thing called Google. I don't know why, but I think so. One of the challenges in this is figuring out what the right public policy is. Right? I've said public policy many times, but one of the things I want to emphasize here is cloud computing in the sense of replacing things like office applications and figuring out your address book for your mail and so forth is actually pretty easy. And I think sometimes we mistake that it takes, large, complicated, expensive software to actually do that. I think all that stuff's going to die. And that will be the easy part. It's the actual, what do you do with the personal data and how do you use it to advantage people? How do you do things like find out more about diseases and outbreaks and things like that? We've done some of that with the data we've had just to expose, what's possible and so forth. But there's a lot of applications like that. And that's all wrapped up in this general area that's called cloud computing. So I think people talk about it in the sense of low-level computation and storage, but it's a much bigger topic than that. I think those are just enabling technologies as opposed to being really interesting services that we can offer. But I just wanted to come by and get a chance to throw some of these ideas into this group. I think this is going to be one of the drivers for the internet as it continues to evolve. I think there's going to be a lot more demand for uplink bandwidth from homes and from devices. I think there's going to be a lot more demand for fairly secure encryption and privacy controls and trust models and so forth. I think all of that has to evolve as part of the internet in order to make cloud computing really take on this full-fledged thing, not just replacing mainframes, not just replacing laptops, but actually becoming kind of a powerful set of services that we can offer to a broad set of global users. But, I think this is an interesting group to think about those issues and kind of toss them around. I would say cloud computing is a very formative stage, and I'm hoping this time it sticks. So with that, I'd be happy to take some questions.
So my curiosity is that you talked in large part about cloud computing and privacy issues in the context of the individual. But in fact, when I look at cloud computing, I see tremendous opportunities and challenges for businesses and also for municipalities. I've had some interactions with municipal governments which routinely are starved for computing power, often are not backing up their tax records and other sorts of things. I mean, the disasters are rather profound. But also small businesses where routinely the founder of the business has a vision about what she or he is trying to achieve, and becoming a computer specialist is not part of that process, and they often realize at some level that a lot of their important corporate assets are sitting on that laptop, which they're not backing up enough and so forth, but there are too many other things in front of them. And I say that, and I understand all the accelerators that would also be provided to a small business owner with cloud computing. But I'm saying there's an opportunity there, but then you come back to the question of that data is their business, and at some level your privacy concerns from the cloud and the question that we came up with in a previous session about suddenly the fact that it's off your premises, and so the ability to have it subpoenaed because it's in the hands of a third party goes up, become even more acute than they do necessarily for individuals, perhaps. And I just wondered on your perspective.
So you're right. I concentrated on individual users here. All that's true. And for example, the Google Docs stuff that we put out is pretty heavily adopted by a set of startup groups and small to medium businesses. A number of municipalities and so forth have jumped on. Now, of course, the offering price for them is the right one, which is zero, right? At least for a lot of them. I think there's some profound issues here. One of the reasons I said public policy about 15 times in my brief set of comments is the issues here are not fundamentally technical. It's a question of what are we comfortable with, right? So for example, I can say in these Google applications, the docs and the mail and so forth, one of the challenges talking to businesses about whether they would like to move their data to Google to host, in effect, is they want some assurances about the security. There's lots of legal questions like who can subpoena my data? You know, if your data center's in Europe, what does it mean? If your data center's in the US, what does it mean? If it's in Asia and so forth. I've talked to some small businesses and some government people in Australia who would, strangely enough, prefer that their data not be accessible by people who can have the U.S. Patriot Act enforced against them, right? So I'm not an attorney, but the public policy questions are fundamental here. And so one of the I think there's going to be a lot of questions about liability, governments, and so forth. And by the way, there are a number of governments that are moving towards insisting that these kind of services be offered in country. And as that happens, you know, I have the same reaction to it. You know, Google in some sense is a global organization. We're trying to provide global services. This will tend to nationalize things, right? And the internet tried to avoid that. I see this as another round of various governments trying to factor into their current set of laws and regulations, how do we actually live with this? And right now they can't. So we need a very vigorous debate around what's the right contract law, what's the right, you know, kind of opinions at the governmental level in terms of national security and so forth. They're very challenging. But you're absolutely right.
Hi. The question that's partly about data and partly about the applications that we can run against that data.
Okay.
One of the tendencies has been with more centralization of the data is a less choice on the applications we can run against that data. Once that data is up on Flickr or on Gmail,
yes,
then
that's correct.
You know, there's only one application. It didn't used to be like that, right? I'm partly channeling Monica Lamb, who, you know, my colleagues at Stanford, who has been bending my ear about this for the last few months. But I think she has a very good point that that at some point in the future, presumably and hopefully, we're at a point where the data that we're holding is under our control, and who can see that or that anybody else is holding is under our control if it's the data about us, and that we have some choice over the application that is using that data, and that seems slightly at odds with the way that we're going. It's certainly not technically infeasible. So what's your take on how that plays out?
That's a very complicated question, but I'll try to at least give it a partial answer. So for instance, we're actively looking at, could we expose one of the primitive tools we use, which is called MapReduce, to let people look at sets of data. And I should self-identify myself. I'm like an old Unix guy, so to me, all data should be streams of bytes, and we shouldn't add all this horrible metadata and formats. And so because that's all evil stuff. So I think introducing more general programmatic interfaces is something we need to look at. The problem is when you add very general interfaces, and my colleague, I think Eric Gross was here yesterday, the security people get nervous. I'll characterize it that way, that maybe that's not such a great idea. So there's some interesting things there. I think the other thing for me is, what's your audience, right? Sometimes when I talk to people about what they want to do with cloud computing, I find myself in the supercomputer wars again. They want to talk about very large-scale batch processing for weather and so forth. The real world for most people has become their grocery list and their, you know, what's my task list for this. So people who use computers, and even some quote-unquote programmers who by which programming now means writing Excel macros and, you know, things like that. There are a set of people out there who view computers through applications and wouldn't know how to write a line of C code or C++ code or Java if their life depended on it, right? So I think one of the questions is what level do you come in? As a professional computer scientist, I would rather come in at the code level and get down to it. Most of the user community now views web apps as basic building blocks on which they add things, right? So I think part of it is what's the right set of abstractions to expose, and what are most of the users going to use? It's a hard problem.
Or Facebook APIs, right?
Or Facebook APIs, absolutely. Facebook, I wonder what that is. Yes.
So actually, Bill, I think I'm probably going to go down a similar path to Nick. I've been observing the cloud computing phenomenon and noticing that first it's a buzzword, so
It is a
definitional. There's some definitional problems with it. But setting that aside for a moment, there are a number of organizations that characterize what they're doing as cloud computing, and some of the Amazon and Microsoft.
It's a very popular term with startups who are looking for funding.
Yeah,
too.
also true.
Yeah. So.
But pretending for just a moment that there is actually some commonality among all these assertions about we run clouds, I've been thinking that the ability to move information between clouds might turn out to be an important capability. And I have the feeling that we're at the same place in that context as we were 30 years ago when there were networks, but they didn't talk to each other, because there wasn't any way for one network to refer to another one because there was no vocabulary for that. And I keep thinking, well, we promise people that they can take information out of our cloud and put it elsewhere. It means we have to have interfaces to do that. An example, I'm taking stuff from Cloud A and moving it to Cloud B, and it's protected in Cloud A under some set of references to who has access to the documents and who can do what to them. That's metadata, which I understand you consider evil, but I'm going to have to point out that that is maybe a necessary evil to deal with access controls. But if I want to move the data from one place to another, I'm going to have to also express not only what the data is, but also what the access controls are and everything else. I don't think there's any vocabulary for that, and I guess my primary question is whether you would agree that that's an area that's worthy of research and development.
Having mentioned it, I think you should absolutely and immediately trademark the term intercloud to prevent other people from getting at that and avoid
oh, thank you. Yes, I failed to do that in the other case.
No, it's clear that in the same way the internet evolved by developing some open standards and so forth, we need to do the same thing here. I think part of what I was trying to say here is that I believe the most interesting aspects of the cloud stuff, which is, as you point out, a buzzword, is tackling the lots of data, making the endpoint devices stateless and so forth, going fairly far up the application stack. It's absolutely the case that the way the data is stored and accessed, so the low-level storage stuff, the APIs, the wireline protocols and so forth, we need to agree on that, I think, as an industry and as an academic community, and work towards a common set of things so you can move stuff around. Now, in the same way with the internet, people will fight that because some of this is proprietary advantage. We'll go through the usual debate. But I think the other thing that's important is I think people are going to want to be able to pull their data out of the cloud or occasionally make backups out of the cloud. I'm still one of these people that doesn't believe, even though I've been told 9 times that data's backed up, I still try to keep personal copies of it because I don't kind of believe anybody that they actually backed it up. So
glad I'm not the only paranoid in the room then.
But I mean, I think a set of interoperability standards are going to have to be created at particularly at the storage level, the low-level storage level. I think I'm the only thing holding you from lunch, so I should.
Thank you so much, Bill. I really appreciate it.